motorcycle needs the first time 1,000 kilometers maintenance. Cars, after that, they have the normal 5,000 kilometers maintenance. Okay, so let's assume that for this MTBF, or first file failure time, let's put a by expression. Remember that we have statistical distributions, many options. By expression means a standard value. The by expression default value is 1, which means 1 minute. So let's put it in 500 minutes. Okay, let's assume that in 500 minutes this machine will need a maintenance. And now I have n mean time before failure. Okay, so I will see here I have a statistical distribution 0, 1000, so I will change it for by expression, and I will put again 500 seconds, just for the sake of this experiment. Mean time to repair. So in mean time to repair, I will put sorry, I pressed the wrong button. Mean time to repair, so let's put a by expression. Okay, and I will put again let's say 100 seconds, according to what I already wrote in the computer lab PDF file that is uploaded to Moodle. So I will put 100 seconds is the time to the machine to be repaired, the time that the technicians or engineers will spend fixing the machine. Okay, so again I have to come to tools, and now I have the window for the maintenance. So I open it because this is the one that I'm working, because I'm working in functions. Okay, first time failure, MTBF, MTTR, down function, resume function. We will not use in this exercise right now, but we can test it later. Now I'm going to members. What I'm telling is what are the members of this first parameter window that will have this sort of problem. So I have to tell the system that the processor 7 is the one that I want to do the maintenance. So I put the member of this schedule for maintenance is only processor 7. That's very interesting because you can see you have several objects, all the objects in here, so you can put more than one object. Okay, but if you want to remove from the membership of this parameters window, you just press the second button and that will be fine. Okay, so let's say apply and OK, and let's see what happened now. The first thing that I want to do is to change the stop time. The stop time, say, is 1000 seconds. Let's put it like 550 seconds. Set, and you see the stop time here. What it means is that because the machine will have the first stop at 500 seconds, I will see what happened with this machine, how the system advised me that this machine is in maintenance. So let's do reset and run. Well, it's a little bit fast, and you see the run time in here. Okay, it's going to 400, 500, and the system stopped in 550. What it means is that at 500 seconds, this mustard color box is telling that the machine is in maintenance. Okay, and in this maintenance time, nothing will be produced. Okay, because it stops exactly in here. So the products are still waiting for the machine to keep working. So the last step that I want to do for this presentation is to show the statistics of an object. I will choose the processor, and in the processor I will click on the statistics tab, and you can see now two options. The one is the state and a chart button, and record data for content and state time chart. I will deal with this in the next class. We will do this one in more detail. Response to the model number 5. I already have prepared it. I have here the queues, the processors, and a new queue and a new processor. So let's start fixing the different characteristics of this model. Right. I stand along queue, first in, first out, feeds 4 parallel stations. So we have the 4 parallel stations, and item arrives at the station every 21 seconds from the source. So let's change the source and let's fix it to be 21 seconds. So how we can change it? In the inter-arrival time, we have a statistical distribution, but we want to change by expression. What do I mean by change by expression? That means that exactly every 21 seconds will be arriving. So you have to check what is the arrival time for your research projects. Apply and OK. So the second thing is the time of testing is 1 minute in each processor. So time of testing is 1 minute. So how can we change the time of testing in each station? So these are the 4 stations. So let's change the time of process. We say here process time, and we have to change it to 1 minute. How can we do that? By what is it? By expression here, and we put 1 minute, which is equal to 60 seconds. Remember that we always have one unit to measure time, which is seconds. Okay, we will see how to change to minutes, to hours. We will do that a little bit later. Let's copy now the characteristics of this processor in the other 3 processors. So press Shift again. You already have done that several times. Select the new processors or stations, and then click on the processor. Right click of the mouse, and we go to modeling utilities, edit, select objects, edit, copy from highlighted to all variables. Okay, so you already are experts doing this bit. Okay, let's check now the information sheet and let's read what we had to do next. The testing stations processors stop every 20 minutes exponentially distributed and spend between 2 to 5 minutes uniformly distributed to repair the station. The rate of failure in the station is 10%, which means 90% are okay and 10% are with defects. The items with defects or failures are repaired manually in a separate station. So where is that? This is this station that we have here. 10% are coming into this queue and then to this station to be manually repaired and then go back to this queue to be processed again. Alright, so what we have to do is to go to the main menu, tools, to MTBF and MTR, and press the button add. Okay, so and then the parameters window come and we can change the schedule for maintenance. So we come to functions. Remember that we have first failure time. This is the first time that the machine needs maintenance. We already have done that in the last week lab. So the computer labs says that NTBF for each testing station is exponential 0 minutes 20, 1. So let's do that. So let's find in first failure time the statistical distribution, and let's put exponential. What is exponential? Well, actually it's already in here, exponential. Okay,